right, thanks, Allie, and just want to thank all of you for joining in today as well. Appreciate your attendance, and I hope you find it useful. As Allie mentioned, feel free to ask questions. We are here to help with those questions. Hopefully we can address those so that you get the most out of the time here today. As we get started, there are a few topics I guess I just wanted to highlight before we move in to directly talk about civil sales and design intent. The first thing I just wanted to highlight is what we call Connect Advisor. And Connect Advisor is a new development, and it's available across all of the products here at Bentley. But Connect Advisor is really an application embedded into your Bentley software, whether that's En-ROADS, Geopack, MX, whatever that may be. But it provides for in-product content, searching, querying, and collection of data. So here on the screen you can see how Bentley Connect Advisor, within the product, you happen to be running Power En-ROADS, for example. You're able to open up Connect Advisor from an icon embedded in the software, and you're able to search. You're able to search the Learn server. You're able to search the Bentley communities or the YouTube channel all at the same time. So ultimately, the Connect Advisor is intended for making the search for helpful information, whether it's in the form of training or videos like you see here on the screen. We want to make that easier to get to. So here you see the in-application playing of the video that relates to civil sales. And again, Connect Advisor gives you that ability directly within the product. So it minimizes your external searching, if you will, to find useful information. Also in Connect Advisor, you have access to training. As I'd mentioned, you see the quick starts that are available to you. You can see those on the screen. Also, announcements are available to you, as well as upcoming events and other things that may interest you as it relates to the product you're using. So we just want to, again, make things more easily accessible to you. And Bentley Connect Advisors is how we're doing that. Okay? In addition to that, I just wanted to highlight context capture as well. Many of you may be using context capture, but when it comes to really capturing the reality of our projects, context capture allows us to use photography, whether it's from an aerial or it's terrestrial, and create a reality mesh, which you see here on the screen. So it allows us, again, to capture in place or existing data and then bring that in and reference it via a reality mesh into our project so that we get more live context as to what we're working on. Also, too, just quickly, I wanted to kind of cover LumenRT. Many of you may be using LumenRT as well. As far as animating and visualizing your designs, LumenRT really makes it easy. It puts it in a place, makes it so easy that you can animate, that you can visualize your designs. You don't have to wait till the very end to create a grand production. You can actually visualize that design model at any stage throughout the process. And gentleman, friend of mine mentioned once, you should visualize early and visualize often. And LumenRT lets you do that. So here you can see again just some animation that was created in LumenRT. Everything from capturing still images to creating flyovers like you see here, and really again producing live and useful and effective visualization is available in LumenRT. Now, to get started, we're going to focus today on civil sales and capturing and using design intent inside of civil sales. So as I get started, we're going to focus first of all on design intent. But as we do begin, I've got a question for you guys. If you wouldn't mind just responding in the Q&A box with your answer. My first question is, how many of you have ever created a civil sale? And again, just type yes in the chat window or the Q&A window if you have created a civil sale. And I just want to gauge really you guys and where you are as far as how much you've used civil sales, how familiar you are with them, and kind of go from there. Okay? All right, so good. Thank you guys. Thanks for everybody for dropping a note in the window there. So I see quite a few of you have created civil cells before. All right, I got a follow-up question. In addition, so I can gauge and see how many of you may have created a civil cell or have attempted to create a civil cell. Now, how many of you have placed a civil cell? Simply used a civil cell that we deliver out of the box and placed that within your design model. All right, good. Thank you for responding. Looks like quite a few of you. Okay, good. All right, good. Well, thank y'all for bearing with me there. Again, the point of a tech talk really is for us to share information. It really is about talking. So I want it to be open. I want it to be informative back and forth. So if you have questions, as Ali said, please place those in the Q&A window. Joe, Dan, or myself will do our best to respond to those. We will have a Q&A session at the end as well. So to get started, we're going to come at this from a little different angle. The title of the presentation was using or storing design intent or capturing and reusing design intent in civil cells. So the first question is, what is design intent? And design intent really is at the heart and the foundation of open roads and the tools inside of open roads. So here on the screen, you're seeing how we may have constructed graphical or elements in the past. As we construct these elements, you'll notice that that first line was created tangential to the arc, the others created perpendicular to the arc. And now, as we've all experienced in our life and in our work, what happens when that baseline, that reference element changes? And you'll notice, as has always happened, nothing happens. Those two blue lines, which we created using our design intent, for one element to remain tangential, the other perpendicular, stays the same. So if we continue that line of thinking, and as you watch along here, again, we could begin to construct these elements. And we're constructing them based off of engineering design intent. And you can see here the snaps that we used are not retained. The offsets from the parallel elements, none of that information is retained. So all of those elements basically exist as one element with no relationship to one another, which means that as one element, the red line, the arc changes, the others have no relationship in order to change as well. So design intent at its heart is intended to manage, number one, to capture, to store, and then reuse all of that information that we impart to those elements when we create them. So design intent in open roads is basically capturing the snaps, if you snap tangential or perpendicular, capturing the parallel offset, if one element's 12 feet, for example, from the other element, so that all of that, quote, design intent is captured and stored on those elements. Now the slide here talks about automatic updates, and that's extremely useful. So in this next scenario, we'll see the same workflow presented to us with the same design intent being imparted to these elements. You'll note as we snap that blue line down, we are making it perpendicular to the baseline element. So using design intent, as we create open roads geometry, we're capturing those snaps, which in turn means as that baseline element changes, those blue lines honor those snaps, which again equates to our design intent for how those elements should act and react based off of that reference element. As we continue on here, again, we're using the civil or the open roads tool sets to create geometry. We're using Civil AccuDraw. The capturing and storing of the design intent, as I mentioned, is fundamental across the board in all of the open roads tools. Okay? And as the video continues on, you see here the same application. We're offsetting with a known distance from the blue line and the red baseline to create that angle or that line at 45 degrees back to the intersection point. Okay? Now, as we select those, The relationships are all maintained. That design intent is basically what you see on the screen, and you have the ability to modify it. And you can see now how we've captured that and how it is all relative back to the element from which it was created. Right? So design intent makes perfect sense. It makes perfect sense to think about it in terms of updates, in terms of capturing that intended outcome and then reusing it when we need to modify something downstream, okay? So rules and relationships, they are inherent in the Open Roads tools. They are captured and created when we use different methods to construct elements, whether we do an offset from, a slope to, they're horizontal, they're vertical. They're also captured when we snap in a certain way to an element, also captured when we use civil AccuDraw, okay? So as you are creating the elements in Open Roads, we are capturing and storing that data for later use, okay? So you can see here on the screen sort of the design intent behind that island. Now, what if we could capture that design intent? Not just for automatic updates on a project, and at 30% we have it generated one way with a certain set of criteria for the design intent, and then at 60% that changes. We need to modify the island. What if we could take that design intent, not only use it in one project, but capture that design intent in a certain way, store it, and then reuse it over and over and over again in multiple projects? And that's really, at the heart of it, what a civil cell is. It allows us to take that design intent for standard, typical things, entities that we design and model and capture it, store it, and reuse it over and over again. Okay? That is a civil cell. So let's take a look at that. Now I'll give you a little... I'll show you the design intent here on the screen of what we'll be looking at live in just a second. We have a simple situation here where we have a driveway. And in the construction or the layout of this driveway, we really have about 3 criteria. You can see those on the screen. Number 1, our survey crew has collected a topo line at the right-of-way where the driveway, the existing driveway, will meet the proposed driveway that we've got to tear out and replace when we modify this roadway. So we have a topo, a 3D line along the back edge of the driveway that came from survey. We want the width of the driveway to vary with those 2 shots on each edge of the driveway. And then finally on the front, we want that driveway to tie into the curb and gutter and then taper the top of the curb down and into that driveway. Okay, so let's take a look. Now, again, please ask questions as we go through this, but I wanted to be sure we look at this live versus kind of, and again, we're taking a little bit of a different angle at it. So if it doesn't make sense too, please let us know that. All right, so we know we have a driveway, and we know that there's design intent that's been stored that we can access and reuse over and over again. So within my project here, remember, we've got this roadway that we're modeling here, and the survey crew's gone out and captured these back of the driveway lines, okay? So those could have been generated from topo, for example. And now I've got multiple driveways along the corridor left and right, and I want to model that driveway. Now typically in the past, as you all know, we would have had to create those one by one by one over and over and over again, basically recreating it based off the various widths, the various offsets, and so forth, okay? Now, I know that if I'm assuming here that the right-of-way line, this is at the right-of-way line, we got a bit of a zigzag here, but it happens in the real world, so we'll make that assumption. Now, what I want to do, I'm going to go over here, I'm going to open up the civil cell dialog box. And before we go much farther, let me make a quick note here as well. The beauty of the civil cell is that, number 1, it can be captured and stored. So here you see a library of stored civil cells. These are civil cells that are delivered with the Open Roads tool set. So for the most part, what you see in here is delivered directly out of the box with the product, except for a couple that I've added in just for the sake of today's demonstration. All right? And they exist again in a DGN library back behind the scenes in my workspace. So I've created a civil cell, and I want to just place that in the model. So I'm going to go pick that civil cell. Again, I'm accessing it from the library. Now, a civil cell works. Basically, there's two main things you got to pay attention to in the civil cell. And they are represented on the screen by the red lines and the black lines. The red lines are the references, meaning these are the elements in your design model that this driveway is going to fit to. The black lines represent the design elements that will be created in the model. All right? So I'm going to pick that driveway, and then I'm going to follow the prompts. Now, another important part here in using and reusing civil cells is notice the prompt on the heads-up dialog. Now, for example, I didn't create this civil cell. And that's the beauty of the civil cells. I shouldn't have to create it. It can be created. The prompts on the cursor can be defined so that you can explain to me what I need to select. So on the prompt, it's prompting me to select the back of the drive that's from the topo. So I'll select that in the 2D view. And then I'm going to zoom in so I can grab the curb and gutter and the flow line. Then select the back of the curb. Prompt changes, select the face of the curb. And then select the gutter. Now those represent the 4 reference files from which my driveway will assimilate, okay? And so now we can preview that driveway that's going to be created. I don't want to see alternatives, so I'll skip that step. And then I am going to go ahead and clip the corridor onto which I'm placing this driveway. And so it's processing, and it's taking that driveway civil cell and then fitting it basically into my design model. So there's that first driveway. Now remember, this is the same driveway civil cell, and then I can propagate that. I can continue placing that along my corridor. And again, I'm just picking elements one by one by one. We can see the preview, and we'll click through the prompts. Clip the corridor and data point. So it makes, in this case, in the case of driveways, again, we captured that intent, and now we're utilizing it from the library over and over and over again in a real project. And we can see that here being placed. Now, one thing, let's move to the south side. One thing when it comes to civil cells is the direction of elements. So let's move this driveway onto the south side of the road. And again, follow the prompts. And again, I'm just selecting the same elements. And so now you'll notice that directionally, stored in the element, there was one direction. Now I'm going to modify that. You'll notice the arrow here. So upon placement, I do have the ability to redirect all of the reference elements, and therefore basically move that driveway onto the south side. So directionally, we have the flexibility on placement to change that. And again, click through the prompts, and we'll accept it. So the civil cell, again, based off the design intent that's imparted to it, becomes the basis for us to get all of these driveways placed in our model. And let me rotate again here, so we can see those being placed in that model. Okay, so the idea would be to generate that civil cell and then reuse it throughout this roadway corridor. Okay, now another example would be, let's take a look at this intersection. And again, let me rotate this view around. Understand that when you, and we'll take a look at this driveway for just a second. Let me Alt-tabbed over to here. So let's talk about this driveway for just a second. Then we'll move back into the intersection. Note that that driveway, and one thing about civil cells is really we've sort of called it, and you need to think about it this way, at least for me it makes perfect sense. Civil cells represent sort of a visual macro. So this is the basis of the civil cell we were just placing in our model. All right, it existed in a separate DGN that I created. Now, here you see as I select the edge of pavement of that driveway, you can see the rules, the relationships, the design intent that was built into that geometric element. Okay? Now, the beauty of this is, based off of the visual programming that I built into these elements, even before it's a civil cell, notice how design intent allows me to show the modification of those elements. So as that back of the driveway moves around, I'm able to see that dynamically change within within the model. Now when we are building civil cells, again, this is a visual macro, and we are, in some senses, programmatically defining how these elements should act. So upon creation of that civil cell, it doesn't matter that the civil cell, in this case, has a sidewalk width for the driveway, or it doesn't matter. The civil cell, the geometry, the relationships, the design intent, and the design intent and the rules are built such that the width varies. So in the design model, that may not be 5, of course. That may be 24.25. Okay? And upon placement in the model, it adjusts accordingly. All right? So think about civil cells. Think about the creation of the elements in a civil cell as a visual macro. We are programming the relationships, we are programming the design intent into these elements so that we get the proper reaction when something changes. Okay? Now, let's move back into our other file. All right? So let's take a look at another example. And here we've got, again, just a simple T intersection that we want to take a look at. Because we have to realize that civil cells are not static. We are not recreating a graphical representation of an entity and reproducing it over and over again. We are capturing the intent behind the relationship of these elements based off references that we'll select and reproducing that over and over again. Okay? So, let's look at this intersection. Again, I'll go back into my civil cell library. And I'm going to grab, again, just a very straightforward T intersection. Now, follow the prompts. Now, this was created, stored in the library for me to use and access over and over and over again, selecting the prompts. Now, remember, as I'm selecting the reference elements, those are predefined. Those are the elements that my civil cell and the results will be created against. So I'll select now that edge of pavement, and then we'll see the layout. So there we can see the layout. I'll clip the corridor, and let's accept it. And so it'll process, and it's going to create that intersection. It's going to clip out the area adjacent to the intersection throughout the corridor. And then I want to take a look at, after placement, what we can do with that civil cell. Okay? All right, so we see now that civil cell has been placed. And recognize, too, that a civil cell is really a compilation of elements, a compilation of civil design elements packaged together based off of their rules, the relationships that bind them together, captured and stored and reused over and over again. So it's not just a terrain model, it's not just an alignment, it's not just a profile, it's not just a corridor or a linear template run. It's all of those things potentially. All right? So here we see that intersection. We see the placement of that intersection, and we can just take a look now. Notice if we zoom in here, if errors should occur, let's take a note. Our adjacent corridor, we've got 3 pavement layers here. And let's take a look at the pavement buildup based off of what was in our civil cell. And notice, just very basically, simply you have 2 layers within the intersection and 3 layers within the roadway corridor. So how do we manage that? Again, a civil cell is not a static entity. All of the flexibility that design intent gave us to make changes within a single project are propagated into that civil cell so that we can make a change in not just a project, but all projects. So for example, we see that component, we see those pavement layers, and we want to make a change to them. There needs to be 3 layers. We need to make that intersection coincide with the roadway pavement layers. So I'm just going to pick the terrain model and the surface template associated with that terrain model in the civil cell and make a change. And so I just want to make that intersection coincide with the template that's being used in the roadway corridor. And there's the template that's being used. I'll select it and say OK. And so now if we look now, that intersection civil cell has been modified and the pavement's been updated to reflect the same as what is in the roadway corridor. All right? So again, civil cell is not static. Changes can be made. All right? Now let's put the pieces together here and take a look. So if we pull this forward, and I'll just get it close for now. So we'll pull the corridor up and have that match the intersection as well. And now let's take a look. And we can note again a couple of changes, a couple of errors. So as we come around the sidewalk along that right-hand side of the intersection, we can see the offset of the sidewalk within the roadway corridor is a little different than the offset of the sidewalk within the intersection. Now, how do we handle that? Again, those individual elements or I won't use the word components, those individual design elements, whether it's a linear template, a terrain model, a surface template, a horizontal geometric element, whatever it may be, are live and you can edit and manipulate those. So just as a quick example, if I need to transition that sidewalk and the buffer between it, I can do that. So I'm just going to move into that civil cell and select that corridor or that linear template drop, and I'm going to just use target aliasing real quick, or parametric constraint, sorry. I saw the target aliasing icon and that's what I said. We're going to use parametric constraints in order to change that buffer offset from beginning to end, okay? So I'm going to just lock this to the beginning and lock it to the end around that radius. I've got a constraint label. You see that buffer width there. That's what I want to modify. I want the start value to be 1.5 because that's going to match the sidewalk along the main line. So I'll leave that at 1.5, but the stop value, I need that to be 3. And I'll data point to do that. So as we process that change and as we make these modifications inside the civil cell, and I did it backwards, I'm sorry about that. As we make changes to the elements, I did it backwards from start to stop. As we make those changes, you see them propagated within that civil cell. Okay? So again, all of the data isn't static. It is available for you to edit and manipulate in order to meet the criteria that you need to match. Okay? So let's bear with me here. Let's go look at the corridor object. I'm looking at the clock as well. We've got maybe a minute or so. So we got start value should be 3. we'll reverse the direction of this. I don't want to take too much time on it. And ultimately the point again is really the civil cell isn't static. It doesn't force you to take all of the values as it was stored and placed. You have the flexibility to make those adjustments in your design model after it's been placed. All right? So there we go. That looks a little better. So I've changed that. I have that tapering now from 1.5 out to 3. And we could do the same for the same corridor, for the corridor that's filling the gap here between the two, or excuse me, the linear template drop. So I'll make a quick adjustment to that. Let's create that parametric constraint. And we'll go from the start to the stop, same. We're going to maintain a constant 3 foot width, and then data point through the prompts to accept that. Okay? And so we'll give that a second to process. Now, in terms of, again, there you go. We can see that now changed. So even upon placement of that intersection civil cell, all of those elements are able to be changed. We're able to make modifications to match those elements. So we can see that and make those changes. Now, one other thing I want to cover, and I know our time is a little short, but I want to go over this if you would just bear with me for just a second. In terms of civil cells, it's really, again, just the creation or the compilation of design elements and placement inside our design model. We've seen that we can make modifications to them. Another instance that you may find yourself wanting to take advantage of is in viewing civil cells. Can I place a civil cell in a civil cell? And so let's take a look at that scenario. So for example here, if I want to place an ADA, a sidewalk ramp inside this model, we can do that. So I'm going to just place what will be the center line of the sidewalk ramp in the model. And so we see that placement of that there. Now another important point when it comes to civil cells. We can access civil cells from multiple sources. Ideally, the civil cells will be created and stored in your workspace in a library or a DGN lib file behind the scenes so that you can access them via the workspace. But here I've referenced in a sidewalk ramp. I've just referenced it into my file, and I'm going to use that reference file, which contains a civil cell, and place that into my model, into my DGN. And I can do that again. I'll just place the civil cell. I'll right-click. Then I'm going to go and select that sidewalk ramp civil cell, and we just want to move over and follow the prompts. So I'll follow the prompts, pick the front top of the curb, back of the sidewalk, go to flow line, and those are our 4 references that we need to select. And we preview the placement, pick the corridor that we want to clip, and then data point to accept it. And so let's close that view. And so now we see the placement of the sidewalk ramp civil cell inside of the intersection civil cell that we placed originally. Okay? So ultimately, let me change the stroking along that arc to densify to densify the triangles, and we'll close in that gap a little bit. But ultimately, civil cells and design intent go hand in hand. You can't have a civil cell without design intent. Design intent, again, is fundamental across all of the Open Roads tools. Everything from horizontal geometry, vertical geometry, terrain, corridors, and so forth. Okay? So that all is a piece and a part of the Open Roads tools. That design intent then in turn allows us to be able to capture and store those elements, whether it's an intersection, a ramp, a driveway, a crossover in a divided highway, an island, a median, whatever that may be, and reuse it and propagate it over and over and over again. Okay? Now, that was quite quick, and I hope you've had questions along the way. Let me change over once more. I don't want to. I've got several slides, but I wanted to cover it live rather than talking about it through a PowerPoint. Okay, so again, I hope that makes sense. What I want to do now, again, we are open for Q&A throughout this session, and we will hang on the line for a little bit of time to handle Q&A as far as what's been asked along the way. Here's a couple of links. I just want to point this out to you. If you want more information as it relates to civil sales, there is training content available. I can make these links, I can distribute these links in the chat window or in the Q&A window potentially, or we'll put them in a follow-up email. That's what will happen. But be aware that on-demand and instructor-led training is available, and always take advantage of Bentley communities. There are a wealth of information, of videos, documentation when it comes to creating civil sales of all types. So take advantage of both of those resources. All right, so with that, Allie, I'll turn it back over to you for just a second, but please know that we are available for Q&A, and we will hang on the line. So if you have questions, please drop those in the Q&A box, and we'll do our best to respond. So Allie, I'll turn it back over to you for a second.